What is going on, guys, and welcome back to another video on my channel. Today we're actually going to be looking at something in advance before we've even learned about it, kind of like my the beauty of math video. Yeah, let's just have a look. So the setting is as follows today. We have a triangle, a right-sided triangle. So we have one angle here, we have another angle here, and we have a right angle right here. And now the question is, guys, the question is gonna be, what are these two sides? Now I have not written any values there yet. That's because values are pretty interesting. So we have x and x plus 2, right? So you guys thinking, oh well, how am I gonna solve this? You know, it's unsolvable. No, of course it's not unsolvable, otherwise I would not be doing this. And the longest side is 8. So what are the different approaches which we have in a right angled triangle? So some of you guys might say sine, you know, which we've learned already. So some of you guys might say sine, some of you guys might say cosine, tangent, of course, you know, tangent, all those things. Some of you guys might say, I don't know, the area is equal to something. But no, guys, today we're going to keep it very, very simple, actually. And that is going to be the actual solution to this problem. Let's have a look. So, the theorem that I cannot speak. As you guys know, I'm famous for not being able to say, I mean, on my very small subscriber base at the moment. But I'm not able to say the name of this theorem. But let's just say that Pythagoras was the one to invent this theorem, and it states that the two sides in a right angled triangle squared and added are equal to the longest side in the right angled triangle. Good. So let's get this out of the way. Let's actually have a look at how this is going to help us. So yeah, let's just do some calculation, right? Good. So what do you guys think? Let's just maybe plug it in, right? See what we get. All right. So let's just define this here. So why does this help us? All right. This is just for me to for you guys also to visualize this. So we have A is this A, B is this B, and C is this C, and this is of course the same as all of these three sides. Good. Let's plug that in. So we have A squared, which is just x to the power of 2, right? I'm gonna write this in brackets, guys, because this is important every time that you have something like this, which is actually the reason that I wrote it in brackets. So we have x plus 2 in brackets, right? Remember, the square is squaring the whole thing. If you square this whole thing, I just made a video about equations, right? Squaring the right side means squaring the left side means squaring the right side, right? So let's do this. So we have, I'm gonna put the A here, so make that visible for you guys. So we have A here, we have B right there, and of course don't forget the square right here, and which is just equals to 8 squared, right? We know what 8 squared is, it's 64. We can do that in the head, no problem. Great. Let's continue now. So let's actually multiply this out, and this is where the next video of mine comes in. I will upload another video which will talk about quadratic equations and linear equations and functions in general. So I'm very excited to do that, guys, to share my knowledge. Anyways, x squared plus brackets. Let's actually multiply that out. So I've already made a video about these formulas, binomial formulas. So we have x plus 2, which is equal to x squared plus 4x, and then plus 4, right? That's right. No. Great. So we have x squared plus brackets, x squared plus 4x plus 4. Now the reason, guys, that I put this in brackets is because sometimes you find things as like 2 times b squared, you know? Or, very, very good example is if there were minus here, guys, I would have to swap every single one of these pluses for a minus. So actually that's why I write this in brackets. Usually when I do this myself, I usually do not write it in brackets because I know that I have to apply these rules, but for you guys, I'll write it in brackets, and it's also nice for me to actually visualize and do it more slowly. Alright, anyways. So let's actually have a look. So we have x squared, and now we just open this bracket up. But there's nothing we have to like think about, right? Because it's just a plus, and there's no multiplication, there's nothing. So we can actually just leave the brackets away. We can just act as if they were not there. Great. Now, something that you guys might be thinking about. Oh, this is what he's going to do. Yes, that's what I'm going to do indeed. So now, first thing always is to simplify, right? So we want to simplify. So what can we simplify on the left side? Well, what I can see right away, x squared plus x squared is just 2x squared, right? So we have 2x squared plus 4x plus 4 is equal to 64. And now guys, there's a thing which most of you guys will have learned already, which is this. The quadratic formula, guys. The good old quadratic formula. Make sure you guys remember this formula. I did not look this up. This is burnt into my head. Minus b plus minus b squared minus 4ac. Of course, the square root of that. And then all over 2a. So where does this help us? Well, there it helps us, right? Because we have an x squared, we have an x, we have numbers. So perfect actually scenario for us to apply this. So which condition has to be fulfilled for us to be actually able to use this equation? Well guys, remember, always is equal to 0, right? So you know that, like, you always put all of the variables on one side and the numbers. So always is equal to 0. So what do? Just as my last video, we just subtract 64 from both sides, and then we get 2x squared plus 4x plus 4 minus 64 is equal to 64 minus 64. Good. Now you guys can see I wrote that very slowly. Anyways, 64 minus 64 just cancels out, right? And we get 2x squared plus 4x minus 60 is equal to 0. Don't forget that, guys. Is equal to 0. So this is our equation which we're going to plug into this. Now the question is, what numbers do I plug in? Like b, a, c? Why don't I just take this? Wrong, guys. This is not what we do. I'm sure you guys know this, but so what we actually do now is we have our a, b, and c all in this equation right down here. So this is actually what we're going to be focusing on. So let me just take my red color, right? Alright, I just had to search a bit for my red color, but I got it. Good, great. So guys, do not get confused now. We're actually going to redefine our variables, right? Because I've already written this with b and a and c, right? So this is only for solving this equation, right? And then we actually take the coefficients of these x's as our new variables. So what do we say? Okay, how do we do this? Actually, I'm gonna explain this in the next video. I'm just gonna show how it's done right now, you know? So this is not gonna be a really explanation video. This is just gonna be one application for you guys to actually see that even before learning it. So we have the 2 is before the x squared, so that means a is equal to the new 2, right? This, again, this has nothing to do with this, right? This is completely new. This is just the same variables letter, but it's something completely different, right? So we have b, it's 4x, so b is just 4. And then we have c, which is minus 60, right? So that's just equal to negative 60. Great. I don't have to write 0 here because I'm just defining something, right? This is not an equation. All right. Of course, although these two are, this is a doesn't matter. Let's just skip over there. Good. So we have all these three new, variables, and yeah, I mean, let's just go ahead and plug that in. So let's just plug it in. Yeah, I mean, nothing to think about there really. So x12. It's not x12, it's actually x12, but I just don't write the comma there. It just takes a little bit of time, so I like to keep it with that actually right in the comma. Anyways, so negative b, so b is 4, so let's just put minus 4 there. Plus minus the square root of b squared, which is just going to be 4 to the power of 2. Let me just write that in here. minus 4 times A times C. Oh, sorry, we're already plugging the numbers, so let's do that. A is equal to 2, and C is equal to minus 60, right? Great. All over 2 times 2, which is just 4 again, right? That's correct. Good. Now, let's actually compute this in our heads or with our brains, not actually with the calculator today, unless there's going to be a fraction, which is going to be quite difficult. Anyways, so x12, I'm actually going to take a bigger pen, but I like this one because it's nice to write with. Anyways, so simplify, right? We just simplify this. 2 times 2 is 4. Minus 4 stays minus 4. And then we have plus minus square root. Square root of 4 squared is just 16. Minus 4 times 2 times minus 60, guys. That's a little bit difficult, not too difficult though. 2 times minus 60 is 120. And then 4 times 480. That's right, guys. Good job. Alright, so minus, don't forget that. We have minus times plus, which is just minus again. So we have minus 480. Close the bracket. Good. We continue. X1, because x1 is going to be plus or minus of your choice. It does not really matter what you write there, but just know that whenever you don't write the 1 or 2 anymore, you have to use in front of the square root the plus or the minus. Good. Let's actually do that now. So we have minus 4 plus, I'm going to use plus first here, 16 plus, or let's just calculate this right away. That's 496 all over 4, and we have x2 is equal to all over 4. Again, the same thing, nothing really new there, just minus square root of 496. All right, now let's actually. This is I really do not know this. In our heads, can we maybe think whether or not 496 is actually a square root where there's 0.0000, so there's actually a good number to, or a whole number which is squared gives us 496. That's the question. So we know that 20 squared, right? 20 squared is 400. Let's maybe see. We have a 6 at the end, so it cannot be 5. So maybe we take, I don't know, like 20. Let's try 24. What do you guys think about that? 24 squared. Let's try that. Let's do this in the head together. So we have 24 times 24, which is just the same as, wait a second, 24 by 24. So how do we calculate this? I've already made a video about this also. So we have 24 times 20. This is the way that I like to calculate this. So 24 times 20. Already I can see this is not going to be the correct answer because we have 496. And this by itself is 480 already. So this cannot be the correct answer because we have 480 plus 4 times 24, which is way too much. Let's try 23. And then I'm gonna plug it into the calculator, right? So if this is not an even number or a whole number, then I'm gonna plug it into the calculator. Good. Let's try 23. So it's just 23 times 23. That's more promising, I think. No, it's not really because it's 460. All right, let's try 22, guys. While we are at it, let's just try 22 squared, which is just equal to 440 plus 40. Nope. All right, guys. I'm gonna pull up the calculator. Yeah, guys. So as we actually predicted quite nicely there, because we said, okay, 22 has to be a little bit smaller because that would have been 484, I think. And we saw that 23 times 23 is bigger, so it has to be between 22 and 23, and that's actually what the calculator says. So, so I think it's a little smaller, right? This is just equal to minus 4, or 4 plus. Yes, right, that's right there. So now what I've done is just split this up, right? So I can say that minus 4 and 4, I just basically just took these two top things apart, and I just said, okay, I'm gonna split this up because this is just very easy. Minus 4 over 4, it's just minus 1, which I wrote here. So this is just also minus 1. And then we have, again, plus here, plus there, minus here, so we have to split that up again nicely. Good. Let's now actually put down the actual value of x. So we have x1 is equal to minus 1 plus 22.27 over 4, and x2 is equal to minus 1 minus 22.27 all over 4. Great! This is our answer, guys. And I'm actually going to plug this into the calculator again to give you guys a bit of a, or the exact number for you guys. So, minus 1 minus all over 4. This is minus 6.5, and then it's just this, minus 1, plus, brackets, let's do it this way, over 4. So we have x1 is equal to 4.56, and we have x2 is equal to minus 6.56 brackets. Alrighty, and we are done with this. Now guys, the only question that I have left before you guys can enjoy your day again after this miserable, no, I'm just kidding. I hope this is fun for you guys. I'm trying really hard to make this entertaining, and I'm trying to explain it as well as I possibly can. Anyways, so we actually get a minus here. What does that tell us? Well, can a length be negative? Can you like measure negative lengths? Can you? No, you can't, of course, right? Because although you can subtract length, you cannot actually measure negative length. So this answer is completely invalid in this example, right? So there's basically no use for it because, as we said, a length, holy shit, a length cannot be negative. So this is our final answer, guys, and this is actually x1 is equal to 4.56. And now the final question here, what does this tell us? x1 is 4.56. What does this tell us? Well, first of all, let's say that this is 8 meters, right? And then since this is 8 meters, we can also say this is meters, right? Because we are doing this all with meters. Let's just put units there, right? As I said, you know, I would have to write meters there everywhere, but you can say that for yourself. I don't do that either. I just write, okay, I know that it's meters there, meters here, meters there. Again, as I've mentioned previously, you cannot write kilogram here. You cannot compare with addition meters and kilograms, or liters and or in meters, right? Good. So what does this tell us? This triangle, the answer that this gives us, this 4.56 meters, says that this triangle can only exist like this as it is when x is equal to 4.56 meters. That's what it tells us, guys. And now you might think, okay, what is this useful for? You know, really nothing in this example, right? This is really just kind of, look, I'll admit it, like, math is not useful all the time. I'll just go ahead and say it straight away, like, I'm not afraid of, you know, admitting the truth, you know. But if you know how to do this, and you have really, like, a thing where you need to calculate this, that you know how to do it, you know. And also, like, I'm not sitting in front of my phone right now, and doom scrolling through TikTok or Instagram, I don't know, anyways. I'm actually, my brain is working right now, you know? And this is what I think is the beauty of math, that you really like, your brain is really trying, you know? You're trying to understand, okay, this is the core concept of this, and this is how I have to do it, and all that and all that. Great, so quick summary, what have we done today? We have said, okay, we have this given triangle, and we said, okay, this theorem right here, Pythagoras actually invented that, and we just plug the numbers in. We define x, a is equal to x, b is equal to x plus 2, c is equal to 8. We just plug the numbers in, then we did some simple math calculations right here. We said subtract 64 from both sides, and then we get this, right? We said this is equal to 0. Easy. Then I redefined the variables, just because I wrote this down previously already. This is the quadratic formula, which I will make another video about. So I just said a is equal to 2, b is equal to 4, so 2x squared to 4x, 4 minus 60 minus 60. Simple. Great. Now I just plugged all of these values in. So for b is equal to 4, minus b is just minus 4. 2a is 2 times 2 is just 4. And then b squared, which is just 4 squared, which is a 16, minus 4 times 2 times minus 60. 60 minus 480 is square root of 496. Then I just went ahead and simplified. Minus 4 over 4 is minus 1, which I wrote here. And you have plus 22.27 over 4 and minus 22.27 over 4. Then we said this is x1, this is x2, but then we said a negative length is invalid. Let's just write meters here also. A negative length is invalid, so we cross that out, and the only right answer for this example, for this question, is 4.56 meters. I got my cap for the pen, and I will not let you guys go just yet, because one more thing. Now that we know how long these sides are, let's compute or calculate. Compute is usually with the computer, so let's not. I just like saying that because actually you're computing something. I think it's just funny to think about it that way. Anyways, let's try to calculate these angles, right? Calculating this angle, how big is this angle? Of course 90 degrees, it's a right angle triangle. Great. So let's have a look at this. So how would you guys do this actually? And even, is this even correct what I just calculated here? Now, you guys will see this, probably go like, yeah, this is correct, but how can we actually prove this is correct? Good question, guys. So, let's have a look. How can we, let's just write proof here, right? Proof. So, what is the proof, right? We used this as a basic statement. When we started this calculation, we used a squared plus b squared is c squared. And so we can use this again in calculating this. So if I plug into the calculator this 4.56 squared plus 6.56 squared, it should give me around 8, right? The reason that it's not exactly 8 is because I wrote the approximate values here, so I should have put an approximation sign there. I didn't, right? So this should give me a little bit less than 8. Let's do that, guys. To show you guys that I'm not lying currently, it just said 8. And if I pull up the history, you can see the calculation that I did right there. Right down in this corner. Right here. Great, guys. So we did get this correct. And yeah. So we said, okay, let's actually calculate these sides. Let's do that. The reason that I, just a quick mention, the reason that I got exactly 8 is because I plugged the exact values into this equation, and then it should give exactly 8. Great, good. So proof is actually correct. Very nice. Proof is correct. Great. Angles, let's calculate them. What functions do you guys want to use? Let's use cosine? Alright, let's do that. So, some of you guys might remember this. Cosine, let's write it down in the normal form, like the definition form, you know what I mean? So cosine of any angle is equal to the, closest side divided by longest side, right? That's right. Good. This is the basic definition. Now, let's look a little bit further and let's just say, okay, this is our angle alpha, which we want to calculate, and closest side is x plus 2 and the longest side is 8. So cosine, let's just plug this in, cosine of our angle is closest side over longest side, so x plus 2, so it's just 4.56 all over 8 plus 2, of course. Great. What? How? Well, why doesn't this say this angle is equal to? Because we haven't really learned what this means. You know, we have cosine of alpha, but then it's just an expression. How can we calculate the angle? Glad you guys asked. There is a operation that is the exact opposite of the cosine, and that is arc cosine. So what does that actually do? It is basically the inverse function of cosine. So cosine gives you a value, right? or cosine of an angle gives you the value. So let me actually write this down in red. So cosine of an angle is value. And remember, this value, where can it be, right? Value is between value, and we have -1. -1 bigger than value, and then 1. So we have -1 can be as equally big or bigger than the value, and then 1 the same. So we have basically from -1 to 1 we can have the value of cosine of alpha. And so again, so we have to plug in an angle to get a value, and we just do it in opposite. So we have cosine of an angle gives us a value, right? And then we just have the value can go from -1 all the way to 1, right? So -1 is smaller or equals to value, and the value is smaller or equals to 1, right? It's good. And now we just do the same thing in reverse, and we say alpha, the angle, is equal to arc cosine. We write it like this. We write ARC, and then the function that we're using, so in this example cosine, of the value, right? Fairly simple, I think. And then, where can this range from? Let's think. So, where's the cosine actually negative? So we know that in the top right corner is positive, and the second is already negative. So that's actually where we're gonna find ourselves. So we're gonna find ourselves in 0 to value to 180 degrees of rotation. Great. Good. And now we actually can compute this. So going back to this equation right here, our angle alpha is equal to arc cosine of 6.56 all over 8. And this is going to give us a value of 34.915 degrees. Good. And now you guys might be asking, okay, why do we calculate beta also? Let's do that. Do we really need to use a function there? No. Let's not make our life that difficult. You know, we've already calculated a lot of stuff today. So let's just do the simple version. We can say the sum of all angles in a triangle is equal to 180 degrees. And so we can just say 90 minus 34.915 is equal to beta. And that is the same as 55.08 something degrees. Good. Great, guys. That's it. That's it for today. I've already explained all we've done, and yeah, you have the proof. Sorry, that's not the proof. We did the proof. We got exactly 8, so this is actually correct what we calculated. And now we also used some trigonometric functions and got both angles correct. Guys, I want to thank you guys very much for watching today, and wish you all a wonderful day. And yeah, see you in the next one. Have a good day, guys.